let us come to this particular lecture. Welcome my dear students. Let us see this particular lecture on the steel sections, the code and strength calculations of the joint and how the section should be selected. Coming to the steel section here, this steel section, today the main reason why the steel, the main property is of the steel, one is the strength, one is the stiffness, and third one is durability, fourth one is ductility. So as far as the steel section, the material steel when we are using as the structural element, that is like a beam, column, any member when it is manufactured with the material steel, the steel is having this four. One is the strength. Strength refers to ability of the material to resist the load. So this is the, and coming to the stiffness, as I said, the limit state method, one is considered the strength, another one is also considered the serviceability. Serviceability refers to stiffness, that is refers to load causing the unit deflection. So this load causing the unit deflection, that means the structure which you show design, that means the deflection must be within the limits. That means aesthetical point of view, appearance point of view, structure should not bend. That is called the stiffness. And the durability, the ability of the material against wear and tear, that means we can see that the against the corrosion effects, the steel should have the proper strength to resist this one, or in other words we can say the life is to be improved. Normally to have this particular property, we will carry out the painting for the steel section. Coming to the ductility, one of the most important property in the design, as on today we make every structure show design in such a way that the ductility has to be maintained in the structure. The ductility simply refers to not to collapse all of a sudden. So not to collapse suddenly, that means indirectly it should develop some crack before it fails. That is what the limit state of the strength and serviceability means. The material should be ductile. Before it fails, it should give the notice in the form of the cracks. Steel is a very ductile material and it gives a notice. Even in a RCC structure, we design the structure as an under reinforced structure because the stress in the steel reaches, or the load in the steel reaches its maximum value in case of under reinforced section. That means it clearly shows that steel is going to fail first before the concrete. That is why even RCC structure we made it and include the ductility in the structure. The steel is a very important ductile material and the steel gives the warning before it collapses. So these are the properties of this particular steel material, and the last one is an impact strength. So impact is normally happening in a structure, all of a sudden the load is suddenly varying or falling, this causes an impact effect. So under the impact effect and the normal dynamic loading condition, static loading condition, from the point of view strength, stiffness and serviceability, the structure is so designed in such a way that it should possess all the properties of against the strength, against the serviceability. If the structure is maintained well its condition, we will say that the structure is going to be safe. That is the main objective of a design engineer. One has to see these properties in your design. Coming to the calculations of these particular sections, we can say, so the section means the suitable section to be decided. In this particular steel design, we are going to calculate simply the sectional properties as nothing but the section modulus, that is Z is equal to M by F. So here we are going to select the section based on the bending moment and bending stress, we are going to select the suitable section, that is called the design. So checking the section against the serviceability is nothing but the design of the steel section. So we are not going to design anything in the steel like RCC, we are going to select the section based on the section modulus. Coming to the various sections which we have according to steel code, the steel code says IS 800-2004. According to this particular section, IS 800-2004, this is the code which we are going to follow. Accordingly, this particular code, when we refers, the sections are classified in general as one is based on the grade of the steel. So the grade of the steel is the first property of steel section. So this grade of the steel, the available sections based on these grades of steels available is one is Fe 250, Fe 415, Fe 500. These are the various grades of steels available, and in these bars we are going to use in the designs. As far as these numbers are considered, these two, the minimum tensile strength is 250, 415 and 500. So this is the meaning of what is 250, 415, 500. And coming to the shape of the sections, the standard rolled steel sections, coming into the steel design, the different types of sections which we are going to use and the designation of this section. For example, you can take an I section. The I section is nothing but based on the depth and weight. So this designated this section based on the depth and weight. So this weight is nothing but the self weight of the member, and the depth is a vertical dimension. For example, if the section is IS MB 500 at 7 Newton per meter or 70 Newton per meter, it clearly indicates an designation of section is an I section is based on one is depth, one is the weight. So this 500 is refers to the depth, and this 70 Newton per meter is self weight. So an I section is referred with reference to the depth and this one. Coming to your question, the first one, Dhanlakshmi, we are planning to conduct the classes, soon we will get it. The second one, why don't we are not using IS 800-2000. So if we are using this is the code 800-2000 only, by mistake I wrote, this is the new codes. So the steel code which we are going to follow, the new latest concrete 456 this one, and the steel is 800-2007. This is the code which we follow according to this particular, the rules and regulations only we are discussing here. So it is, this is the steel code which we are using in our design. So coming to the classification, this is the code, steel code, and coming to these particular sections, one is an I section, that is whenever IS MB, this is the medium, B stands for B, and the shape is I shape. So the purpose of this I shape here, the why this is more economical rather than normal RCC, we can see this is the RCC beam, this is the steel beam. One can see from this particular value at the neutral axis here, the stress distribution. This is the stress distribution according to our E by R is equal to M by I is equal to F by V according to the theory of simple bending. So this particular one, the most of the questions, as Mr. Singh, Amit, Akhil Bansal is asking, do questions come from IS 1984, that is the old code. So always the questions, as I mentioned, this code is the existing one, steel code 800, this 2007. All the questions definitely will come in your examinations. Steel sections, most of the questions means mostly they are all the concept of the law, we can say like in our regular law the rules, same thing for engineers. IS code book 800/2007 is like a laws only, everything they mention the rules and regulations, these rules and regulations you have to follow. So the second one, the MB stands in I section, this is the meaning as I mentioned. So this one is medium and B stands for beam. So coming to the I section, as I mentioned, the maximum, Mr. Venkateshan, because maximum moment of resistance, the maximum moment of resistance M is equal to Fz. So Z is maximum, M is maximum. And why this particular Z value and why we choose this one? As I mentioned, the steel section is per weight. That means when you are using the section, if you use the shape like this, a rectangle or square shape, if you use it, it is having more area, or we can say that you can see the difference, this one, this much area is going to be saved. And according to the stress distribution, this is like this is one triangle and this half of this particular one triangle, and we can see from this particular one, this is the area which we are not using. That means out of this area plus this one, only we are using 1/4 of this area. Therefore, if we use this particular shape, because the stress distribution, our shape of the member more are related, that is the reason why we calculate the stress distribution. You can see using this particular one, here the stress is very less and accordingly our area is very less. And the stress at the both ends here and here, that is the top and bottom, the stress is maximum. This is according to the theory of simple bending. This one is maximum, this one is maximum. Therefore, when maximum stress, maximum width at the top and bottom, the minimum bending stress at the neutral axis, therefore minimum area. This is the reason why an I section is most economical, why we are using as a beam rather than the shape a rectangle comparatively, because and also the cost is with reference to the weight. Unnecessarily more weight, automatically the cost of the steel structure becomes more. That's why the factor of safety is 1.15 very less, and also the shape is most important with reference to the section. What does MB? As I mentioned, Mr. Shahid Muhammad Ji, I already mentioned here, MB refers to mild beam. So the medium, it is refers to the medium beam. So we have like this same thing, ISLB, ISHB. So L stands for light beam and H stands for the higher side beam, heavy beam. We can say L is light and H is heavy. So this is how the I sections are designated. So is this first class of steel? Already this is the just a first class. Yesterday it was only an introduction. This is the first class. Coming to the second one, Mr. Aryan Raj, it is the just fundamentals of the topic. Now today we started, and coming to the next section, compared to this I section, is nothing but a channel or angle section. So this channel or angle sections are designated by means of its length and length of leg and the thickness. So with reference to these particular angle sections, we will say ISA 60/40/8. We refer the section with reference to 60/40/8. It clearly shows that. So this dimension is 60, this dimension is 40, and here one thickness, here one thickness, average thickness T is equal to 8 millimeters. That means the I section is designated with angle section is designated, that is this A stands for the angle. As I mentioned here, the B stands for beam. The angle section is designated by 60/40/80. 60 is the first vertical dimension, this one. So these angle sections can be equal angle section or unequal. In this case, two legs are different, so we called as unequal angle section. Coming to the same thing, I can designate 40, 40 and 8 So I can say ISA 40 by 40 by 8. So it shows an equal angle section. Coming to this particular concept here. So what is the effect of maximum shear having low area in the middle of for I section? It's a very good question, Mr. Mohan Kumar, is the effect of shear. So the effect of the shear with reference to this one, as I have shown the previous one, as I mentioned, it is nothing but, suppose if you take a simple beam like this, if this is the neutral axis, the bending stress distribution is like this. This is what you studied in strength of materials theory of simple bending. This is the bending stress. And coming to the bending stress is related with reference to the bending moment, and the relationship between shear force and bending moment F is equal to dm by dx, and accordingly where the shear force or the bending is maximum, and according to the equation here the shear stress distribution. So this is the bending stress, this is the maximum bending stress, shear is 0, the bending stress is 0, shear is maximum. So this is what is meaning of the maximum shear having a low area in the middle of the section. So this shear is taken care by with reference to the shear force. Shear force is an unbalanced vertical force. The shear is calculated with reference to the strength of the joints. So compared to the bending, the shearing effect is less here. So even we can see from this particular section, an I section, coming to the I section, so this is the width or the section going to be taken care of the buckling effect and as well as this particular shearing effect. So hope it is very clear why it is low area in the middle, because one is to make this particular bending stress, to make exactly here the less or the bending stress is 0, only to take care of the shear this particular shape is provided to take care of. One is the bending, the maximum, one is the bending, the maximum, one is the shear, this is the area to be provided. Coming to Mr. Gaurav, do we study as per the syllabus of SSC? Sure, Mr. Gaurav, exactly the course is to be designed and already designed. We follow everything, the lectures as per the syllabus without any deviation from this particular one. In addition to this particular one, it also follows with the live lectures followed with the quiz assignments and the mock-up, test series we are going to do, and mock tests also going to do, and finally we are going to analyze you for all the exam and make you the competitive mind for the exam. And coming to Sitharame is the paid course for civil engineering. Please refers to the website Mr. Sitarama, and Gopinath Mande sir's last one cannot understood. The last one, I hope this is the one you are planning, I think so, or the angle section. So angle section is designated with reference to the length of the angle with reference to the thickness, and coming to the stress distribution, this is what you can see, the bending stress distribution M by I is equal to F by Y. So this is the bending stress, F is equal to M into Y divided by I. So using this particular one, we are going to calculate what is the stress at this one. Coming to the RN draws, shear force exists that draw the Mohr circle, and we will found that diagonal cracking takes place there. That is shear stress with reference to the Mohr circle. Mohr circle is nothing but a graphical representation of the stresses. This graphical representation is normally according to your shear strength of soil, tau is equal to C plus sigma bar tan phi. So tau is on y axis, these are the normal stresses, and this particular one and with the planes on which the normal stress shear is 0. So, we are calculating this one indirectly, this is the shear. This is what the Mohr circle, and according to your question, thus draw the Mohr circle. Coming to the next one, please, RRB electronics, it's beyond this lecture. So, surely we will do for you, madam, Deepankar. And coming to the Aryan Raj, this professor is teaching so many new concepts. Thank you very much. And once again, Mr. Rahul Tiwari, Aryan Raju study at series online answer. So, thanks for feedback, and these live classes to be paid, that is, please go through. And these are the practice questions. Use it to go for the practice questions. Definitely you have the questions, we have all the practicing questions in the session in our program. Definitely it will be given for practice to make the analysis and make you exam ready. And thank you. So, let me come to the next topic on this particular one. For all of you these questions, let us see this particular one, strength of this particular section. So, these are the sections and the grades, and coming to the strength of a particular section, the strength here, the strength refers to, one is to the section. So, this section, this is Z is equal to MF, it is nothing but M is equal to Z into F. This M is nothing but the resistance. Resistance means it is nothing but the capacity of the member to resist the bending effect. That is called the moment of resistance. Bending, loading causes the bending, and our section causes the resistance to the bending. That means when the load is applied not to cause any bending, which is known as the moment of resistance. The name itself, moment of resistance. Bending causes the load, causes an external load, bending. Bending is associated with the moment. Moment is resisted by moment of resistance, or indirectly we can say this is our strength of the section. Coming to the strength of the joint. So, in case of the steel section, surely always all the elements, whatever the elements we are going to use in the steel section, they are all ready-made elements. Means totally ready-made elements means manufactured and joining. So, like a ready-made shirt, what we go rather than stitched shirt. The same thing here, every element is going to be ready-made element, just come and join. For example, I have the column, I have the beam, I have this particular beam. So, I am going to make one angle section and make these two like this. So, it is very clear, one column is there, the beam is there, both are going to be joined by means of one angle section and by means of a rivet or bolt. So, the entire thing here, the stability of the section here, it is very clearly depends upon not only the strength factor what you considered, it also depends upon the strength of the joint. So, the strength of the joint means the joint should be very capable of carrying the load. That carrying the load we express in terms of their efficiency and strength. So, this we called as efficiency of joint. This efficiency of joint is nothing but simply, if I take one particular paper, you take simple one paper. So, to make any connections, as I mentioned, these two members to be joined, one angle section to be used. If this angle section is to be used, we can very clearly say that you can see this is a solid paper, means without any holes. So, this is a solid one. That means the efficiency is nothing but strength of the solid plate in the denominator, means solid plate means without any holes. Once to join the connection, I have to use the holes to insert either rivets or bolt. So, once I make this particular holes, so to this particular paper, so naturally you can see all this particular paper, you can observe there is a holes. Unless I make these particular holes, I cannot join this particular one to the elements. Therefore, always I am going to calculate my efficiency of the particular member is nothing but strength of solid plate, strength of the plate. Strength of the plate means plate with the rivets, holes, that means to when once I join it, you will have the holes and there is a reduction in the area, and this reduction in the area means the strength is this one. With this is with holes, this is without holes, is nothing but strength of the joint. So now we want to calculate this particular one, that is a strength of the joint, means the resistance of the member or the connection, the load, that means whatever the load it is acting at a particular joint, so this load has to be effectively transferred, that is called the strength. With reference to the strength of the riveted connection or welded connection or the bolted connection, the connections can be made with three types, either with rivets, we called as a riveted joint, next to the bolts we called as a bolted joint, or we can use the welding and it is called as a welded joint. So coming to this particular one, as Mr. Venkateshan, it is a very good question. Strength of section is only defined for movement. It is nothing but strength, as I told you, resistance against the load. Load causes the bending. So bending produces the bending moment. Against the bending moment, the resistance is nothing but the strength of the section. So here the strength of the section, it is nothing but M value. The moment of resistance, again it depends upon the stress and the size of the or the shape of the member. So as I mentioned, I section is very effective. That is the only reason. One is material, lightweight, the self weight is reduced. That is the reason why I section. Coming to the F, this depends upon the stress. Stress depends upon quality of material. Quality of the material. So if the quality of material is good, automatically the resistance will be good. So hope Mr. Venkateshan is satisfied with your question. Coming to the next question, sir, butt joint. So coming to the butt joint here, so I didn't still come to Mr. Peregu Sudhir, but still your question butt joint. So when I make it like this, two plates, plate 1, plate 2, and if I insert this particular one, so this is the rivet, either the rivet or bolt or anything. So this is called as a lap joint. And coming to butt joint, so this is two plates, plate 1, plate 2. So the plate 1, plate 2 are going to be joined with some cover plate. So this we called as this cover plate which we made and make the rivet. So this is the joint. On either side of the joint, Mr. Sudhir, you can see on either side of the joint, I have only one rivet here, one rivet here. That means we say the single riveted, double cover butt joints. So the cover is on top and bottom. So two covers are there, whereas the rivet is only one. That is what the failure of this particular rivet, you can see here, this is single riveted, the double cover butt joint. So this is the meaning of what is a butt joint here. So accordingly the rivets will be in whether in the single shear or double shear accordingly, which is good butt or lap joint. So it's a very good question, Mr. Rahul Tiwari. So this question is very clearly, as I said, according to our requirements, the shape of the structure, you have to go for butt joint or lap joint. Both the joints are good, and because why this is good means you can calculate always the efficiency of the joint based on the strength. Still I didn't come to the strength, so butt joint is good and the lap joint. So joint you can go any manner, Mr. Sudhir. So you can go for a lap joint or the butt joint. Finally, as a design engineer, one which we makes it, the joint should not break or the joint should carry the sufficient load. That is what we called as the number of rivets or number of rivets which we calculate based on rivet value, the load divided by rivet value. So, in both the cases lap joint or butt joint, so once you calculate this number of rivets, so that number of rivets will takes care of not to cause any failure. So, both the butt joint and lap joint both can be designed for maximum efficiency. We cannot say that this is bad, this is good. Coming to Mr. Naveen Kumar, moment free joint. It is very clearly moment free. That means there is no movement. For example, you can take moment free if the load is passing, suppose this is an axial load, load is passing through the center of gravity, moment is 0. Whereas in case of an eccentric connection, this is the column and this is the beam, and we can see that the center of gravity of this one is here, this is the passing load, this is an axis, so this is an eccentricity, so it causes the moment. So, moment is equal to load is P. So, this is with reference to eccentric joint connections, this is the moment existing. In this particular case, moment is free. It is a simple example, lap joint cause couple is produced bending moment. So, Mr. Ganeshwar Rao, lap joint cause couple, it's produced bending moment. So, the lap joint, as you can see here, this particular one, it depends upon the loading position, and now as far as possible the loads are acts at the particular nodal points, the load is passing through the joint. So, there is no, only it causes the bending moment. Grip length is less than 5 times. As far as Mr. Ganeshwar Rao, it is a good question again related to the grip length here. The grip length is nothing but it determines, for example, if I am having the 2 plates, if I am having, so these are the 2 plates and I have to, this is the connection. That means if I want to insert a bolt, let us take this particular one. So, this is the rivet, this is the rivet, and this diameter, this is called as a shank length. This is the head. So, the diameter of the shank is phi, the diameter of the rivet hole is d. So, in order to insert a rivet into the connection, we have to provide some clearance. This is the clearance. The clearance has to be given, therefore, the diameter of the rivet hole d is equal to shank dia phi plus or minus, that is plus 1.5 or plus 2. We will use the clearance, and this is the grip length. So, the grip length is to have the joint in a very good condition. Our grip length must be, the shank length must be more than this one. Normally this will be taken greater than 4 times d, not more than 4 times d. As you mentioned, it is 50 d, so it is not correct, it is 4 times d. So, this is the value for this particular grip. Hope Mr. Karthik, as you mentioned here, it is 50 d, it is not 50 d. So, this is the d is the diameter of the hole. So, this clearance mainly depends upon if the diameter phi is less than 25, we use 1.5. If the phi is greater than 25, we use the clearance 2. So, I think hope Mr. Karthik, it is clear to you, it is not 50 d as you mentioned, hope you are mistake, and it is 4 d is the, this is the grip length. And always to have the joint should be very perfect, or the connection should not fail, and your grip length cannot be more than 4 d. That means the shank length, if it is more than this particular one, so there is a projection here, the connection is very, very good. The grip length provision is introduced so that eccentricity effect in the lap joint is neglected. So, as you mentioned, the eccentricity effect in the lap joint, eccentricity will cause us only when load is not passing through the center of the gravity. So, as far as possible, we make the eccentric connections. Eccentric connections are designed in such a way such that the resultant force is due to both. One is due to the load, that is the direct load. Another one is due to the eccentricity, the resultant must be calculated as in case of an eccentric connections with reference to Mr. Aryan Raj. So, good question with reference to your, this is your connection if I say here. So, this is the center. So, your bolts are here. So, these bolts are here. So, this particular eccentricity, whenever as I mentioned here, this is an eccentric connection. Definitely in an eccentric connection, the effect in the lap joint is neglected and the grip length is nothing to do with this particular one. So, it is mainly depends upon the number of rivets and the force it is. The resultant force which it is acting, that means if I take this particular one, this is the joint here and you can consider this is the load here, this is the load here. So, you can see this particular one, all this the direct load or the direct stress or the bending stress. So, the bending stress is depends upon this radial distance. So, this radial distance, for example, if you see this value is less, these two bolts are very less, that means they are not in critical and only this bolts 1, 2, 3, 4. These bolts are very critical. That means again these bolts are very critical means they are all from the radial distance same. That means the resultant force which is one is due to the direct, one is as you mentioned in your eccentricity, eccentricity is produced with the bending. So, bending will causes the bending stress, that is M by I is equal to F by Y. Therefore, your F is equal to M into Y by I. So, means M into Y by I you can see from this particular equation. So, F depends upon the moment, moment is equal to load into eccentricity. So, you consider this is E, this is the eccentricity. So, P into E is the eccentricity effect. So, the total effect is one is load by area, this is the direct stress, this is the bending stress. So, you have to consider both in case of eccentricity, bending effect as well as the eccentricity, that is a direct stress, and in plane eccentricity causes twisting and direct. So, in plane eccentricity the direct stress is there, twisting is associated with the shear. That means indirectly in your loading as the shear stress which I mentioned, which is due to the shear force. So, definitely in plane eccentricity cause twisting and direct stress is always there with reference to the direct load, and bending causes bending moment, it is not the twisting, twisting is related with the shear. So, the combined effect as I mentioned the radial direction here 1, 2, 3, 4, if the radial distance is same, accordingly this stress also will be same. So, only the critical position means which rivet will fail first, whichever this among all the radial distance is same. So, this stress is directly same, only the one which is near, for example, this bolt 2 and bolt 3. So, bolt 2 and bolt 3 both are very same radial distance, and again if you compare this particular one, the angle. So, this is an angle for this one, same thing an angle for this one. So, this angle for the bolt 2 and 3 same, and consequently the force also will be same. Again with reference to which bolt will fail first, the bolt which is this bolt is very near to the load compared to this one, this bolt is going to fail. So, this is what mainly we are going to analyze with reference to your twisting. And coming to Mr. Nageswara, is plane eccentricity causes twisting I mentioned. And Gopinath, what is the difference between unique theorem and resisting force? Unique theorem and resisting force nothing to do with this particular topic, and R is maximum, angle should be minimum. So, in your mentioning as you mentioned R, what is R in your Mr. Gnaneshwar Rao, what is R in your? Is it related with the radius of curve? E by R is equal to M by I is equal to F. Are you asking clearly with reference to R is maximum, angle should be minimum? Is it that one? or the radial distance this one. So I consider this one as a small r, the radial distance, and again with this radial distance and angle, it is nothing to do this angle, the magnitude of the force will be changing, because in your resultant equation, it is a very good question, Mr. Gnaneshwar Rao. In this particular question, the resultant force is equal to the direct plus some resultant force. It is a function of cos theta. In your equation, the resultant force is a function of cos theta, as theta is minimum, the theta is minimum, cos theta, theta minimum, cos theta is maximum, force will be maximum. So hope you understood, Ganeshwar Rao. R is maximum, nothing to do with the radius, it is with reference to theta. That means this is the forces, this is the direct force and this is the force due to bending, the angle between them, this angle causes the magnitude, not with reference to the R. So R is also one of the parameter, but I mentioned all these cases as R value changing, definitely the force magnitude is changing, but in this case all R values are same. I think last one, curvature, why it is equal to 1 by r. What is meaning of curvature? The radius of curvature, so this is the beam here according to theory of simple bending. So the beam bends like this, an arc of circle, this is nothing but radius of curvature. So we assume this one as or the radius of curvature. Thank you very much.